Something we have to do quite a bit of is to break one vector into two. And this is particularly important for motion in the air when you break a vector at an angle. For instance, here is the velocity of a human cannonball launched out of the muzzle of the cannon with a velocity of 40 meters per second, which is pretty fast, at an angle of 30 degrees above the horizontal. Well, two things are very important to us. First of all, we want to break the vector and that vector into two vectors. The horizontal velocity tells us how far along the ground this person will go before they crash into the ground again, and therefore where they should put the catch net. And that's pretty important to you if you are a human cannonball, because landing without a catch net is very bad for your health. Now, the vertical velocity is very important too, because if that's large, then the hang time will be greater and there'll be more time in the air. The two are very important. So we need to look at that. Well, we could look at the horizontal velocity first of all. Now, fifth form year 11 trig says that the cosine of an angle will be equal to the adjacent divided by the hypotenuse. The cosine of the angle the cosine of 30 will be equal to the horizontal velocity, in this case because it's the adjacent. There's the angle, there's the adjacent, and there is the hypotenuse. So horizontal velocity divided by 40. We can do a very complicated step now called swapping sides. So we do the horizontal velocity divided by 40 is equal to cosine of 30. Well, we can move along now. To undo the clutter, we want the horizontal velocity by itself. That's a bit of trigonometry, a bit of algebra. So I'm going to multiply both sides by 40. Well, that divided by 40 times 40 cancels, and we just have the horizontal velocity all by itself, which is what we want, which is equal to 40 times the cosine of 30. And the cosine of 30 is equal to 0.866 roughly. And in a previous one I found that that was equal to 34.64 meters per second. I actually rehearsed this before I recorded it. Funnily enough, cosine of 30 is equal to the square root of 3 all divided by 2 as well. So we now know that the horizontal velocity is 34.64 meters per second that way. Now I'm going to break the page up into two little bits. Now let's look at the vertically, because the previous one was horizontally, and I might write that one down too. So this is horizontally. Vertically, we've got a triangle here which has got 30 degrees and 40 meters per second, and the vertical velocity. Well, year 11 trig will tell us that we have got here if there's the angle, there's the opposite, and there's the hypotenuse. So we've got the opposite and hypotenuse, and the one that works for that is sine of theta is equal to the opposite divided by the hypotenuse. So SOH. And so therefore the sine of 30 is equal to the vertical velocity divided by 40. I'm going to do now a complicated step called swapping sides. So the vertical velocity divided by 40 is equal to the sine of 30. Now I want to undo the clutter that's around this. I want the vertical velocity all by itself, but it's divided by 40, and I want to undo that. So to undo the divided by, I'll multiply by 40. But I want the equal sign to still work, so I must do the same to both sides. That cancels. The vertical velocity is equal to 40 times the sine of 30. Well, the sine of 30 is precisely a half. So the vertical velocity is equal to 20 meters per second. And so we have now broken up one vector into two. 34.64 meters per second, and 20 meters per second up. That's up, and that's to the right.